So let's practice solving these algebraically. Okay, so the process is going to be we need to figure out the domain and for the positive and negative possibilities. Okay, so what we're going to do is we're going to say, okay, well, if it's positive, the positive domain, we're going to say that the inside function 2x plus 3 is equal to positive 9. Okay? And then we're going to come up with the negative possibility. So the negative possibility is when the inside 2x plus 3, the calculation ends up being negative 9, because if it's negative 9, the absolute value will still convert it to 9. Okay, so here represents our two possibilities. And again, this gives us the two arms of the V. So going ahead and solving this, I'm going to subtract 3 from both sides. I'm going to divide by 2, so I get x equals 3 as one solution. Do the same thing here. I'm going to subtract 3 from both sides. I get negative 12. Divide by 2, I get x equals negative 6. So these are my two solutions. Now, bear in mind that it is possible to get solutions that don't exist. Okay, because they're possible that we get 0 solutions. So we should check for extraneous roots. So I'm just going to check. Okay, so I'm going to test it. So I'm going to test, and if I plug it in, I get 6 plus 3, absolute value of 9 equals 9. Check. That's a good solution. So I'm going to test, so that's x equals 3. I'm going to test x equals negative 6. So I get negative 12 plus 3 is negative 9 equals 9. Check. Those are both good solutions. Now, again, it's important that we consider that this is, we may get a solution, we may get a solution that doesn't work, because when we look at the shape of the graph, it is actually possible to get solutions, equations that don't have solutions. Okay, so here we'll do the same thing. So before we consider the positive, negative possibilities, we should solve for the absolute value. So I'm going to do that first. So I'm going to subtract 16 from both sides. Do not multiply the 2 into the brackets, especially if it's negative. If it's positive, it actually makes no difference, but we'll get out of that habit of doing that. We're going to solve from outside in. So instead of getting rid of the 2 by distribution, we're going to get rid of the 2 by divide by 2, negative 2. Okay, so we end up with absolute value x minus 2x minus 7 equals 8. Okay, at this point, this is where we consider our positive version. So the 2x minus 7, if it calculates to positive 8, then we'll get the answer. And we also need to consider the negative version here. Okay, so where the 2x minus 7, if it calculated to negative 8, that would still give us positive 8 for our absolute value. So going ahead and solving this, add 7 to both sides, divide by 2, so I end up with 15 over 2 as one solution, and do the same thing over here. I'm going to add 7 to both sides, divide by 2. Okay, so those, I'm going to check my answers. I'm just going to do a brief check here. This is going to be 15 over 2 times 2 is 15, minus 7 is 8, times negative 2 is negative 16, plus 16 is 0. That's good. Okay. Test negative 1/2. I get negative 1/2 times 2 is negative 1, minus 7 is negative 8. Absolute value is going to give me positive 8, times negative 2 is negative 16. Yeah, that one works out as well. So again, the key is, once we isolate the absolute value, we need to consider the positive and negative versions of this. So the same thing here. Okay, we're going to consider our positive and negative versions of this. So we can have the inside equals positive 3, and we can have the inside equal to negative. So 5x plus 7 equals negative 3. So we have our negative possibility and our positive possibility. Go ahead and solve. This seems fairly consistent. 5x equals negative 4. X equals negative 4 over 5. Okay, so that's one solution. And here if I subtract 7 from both sides, okay, divide both sides by 5, I'm going to end up with x equals negative 2. Okay. Now we really should test this. Okay, let's see what happens. If I plug in negative 2, I get negative 10 plus 7 is negative 3. Absolute value is positive 3. Well, that doesn't equal negative 3. This solution does not work. It is extraneous. This is why we need to check. Okay, so I'm going to test negative 4/5. So I multiply that 4/5, negative 4/5 by 5, I get negative 4. Plus 7 is positive 3. The absolute value of positive 3 is not negative 3. So again, this does not work. So this is extraneous. Now some of you may be saying, well, Mr. Lin, why did you even check it? Why did we even solve this? Because we could see that there's going to be no solutions. Because when we try to undo this, we're going to say that the absolute value equaled negative 3. Well, that's not true. Well, there's no solution here. Okay? So the absolute value cannot equal this negative here. So if we recognize that from the very beginning, we can say that we already know from the get-go, because of this scenario here, that this is no solution. So we could actually determine extraneous solutions by inspection here. By inspection, we could have said, yeah, absolute value doesn't equal negative. Therefore, although we can generate two solutions with our algebraic process of undoing, they're generating solutions that don't exist.